Good afternoon. We're so glad you're here for our third webinar in our pipeline webinar series. This is our final webinar for the year, but we'll continue to host the series in Q1 of 2022. We're always seeking ideas on what folks would like to hear about, so please reach out with them and topics that would be helpful for you and your team. We also love hosting webinars directly for our clients and partners, so if you have a topic you'd like us to present to you and your team, reach out. Following today's webinar, we will send out a certificate of completion for you to self-report education credits. Additionally, we're recording today's discussion so you can pass it along to your team. John, if you go to the chat slide, as always, we encourage questions during the webinar, and you can submit them in the chat box, which people have already started using, which is great on the album and music. Additionally, we have some fun today. John and Gary included some trivia questions, so be ready to type your answer in the chat box. The first person to give the correct answer in the chat box for each question will receive an awesome Geoengineers prize. So it's now my pleasure to introduce two of my amazing colleagues, John Robison and Gary Castleberry. John is a principal engineer out of our Springfield, Missouri office and leads our pipelines business unit, which includes over 35 staff. He brings an expertise in trenchless design, including HDD and direct pipe, and geotechnical engineering on pipeline projects nationally and internationally. In his free time, John is a farmer, fisherman, and also makes his own wine. Gary is a senior consultant and a group leader of our pipelines business unit and also out of our Springfield, Missouri office. With over 20 years of experience, he brings significant expertise in supporting the entire life cycle of pipeline engineering and construction projects, having managed HDD and direct pipe installations across the US. In his free time, you can find him hunting, fishing, riding horses, or going to the rodeo. John and Gary both bring in-depth experience, but from diverse backgrounds. So I'd love to toss it over to you, John, to give us a little more information about your backgrounds before you dive into the presentation.
Thank you, April. Appreciate the introduction and also all of your hard work and bearing with my music selections. But it really does take a lot to keep us organized and make this run smoothly. And hopefully this will run smoothly, but appreciate your help. Also, thank you to everybody that's joining us. You know, Gary and I are excited to present this today. We're really looking forward to it, and we appreciate you taking the time out of your day to join us. So, hello, Gary. Welcome.
Thank you, John. Happy to be here. Thank you, April, for everything you've done to put this together.
Yeah. So, you know, April talked a little bit about our different backgrounds and how we kind of came to be sitting here today to give this presentation. And you know, my background, just briefly, is more of a traditional education into consulting, engineering sort of experience, whereas you took a kind of a little bit of a twistier path, an interesting path, working for, you know, you started out as a contractor, and maybe just share a little bit briefly about your background.
Sure. Yeah, John, I right out of high school, I enlisted in the military and spent some time in the military. And when I got out, I started working for a contractor and kind of slowly worked my way up through the ranks in the contractor side. I then started working for owners. While I was working for owners, I had the opportunity to go back to school, complete my education, earning a bachelor's degree, and just recently a master's degree since I've been with Geoengineers.
Right.
And so I've just kind of seen everything from the bottom up, you know, starting out as a laborer, working my way up to operator, driller, and then, you know, into
labor on HDD,
on
HDD sites, and
yes,
actually running the drilling rigs and then managing that work. And yeah.
One of my first jobs was mixing drilling fluid and putting joints of pipe on the rigs and taking them off. So
right, cool.
So I learned it from the bottom up, and it's been an interesting journey, and I think it kind of gives me a well-rounded experience as I look at things through a lot of different lenses. You know, when we encounter a problem, during construction, our you know, anticipate a problem may be, you know, we can see that in the design phase too.
Well, I've definitely noticed that working with you on projects. You know, you bring that perspective, and so when we started talking about doing this webinar, that was one of the things I was excited about. And I'm hoping we can kind of we'll see that as we go through it. You know, the other thing I think we'll point out before we move on is that we wanted this to be more of a conversational, obviously, as we've started it, more of a conversation between you and I. We're going to show slides, but hopefully this doesn't feel like a real traditional, here's the slide, here's talking about the slide, here's slide 2, talking about the slide. It's much more give and take. And with that, we'd like for the folks in our audience to also engage. And if you have questions, please put them in the chat, and we'll stop. April will interrupt. I don't think she's gone fire. We see her little screen there. We don't see her face at the moment, but I think she's near, and we'll be able to interrupt, and we'll take those questions and have an interactive presentation that way. And also, we alluded to the fact that we've got a couple of trivia questions along the way. So in order to win that fabulous prize, you have to be the first person to answer the trivia question in the chat. So if you haven't figured out how to do chat on Zoom, you might practice a little bit here for the next few minutes before we get to the first one. So anyway, without further ado, let's jump into it.
Sounds awesome.
So we like to start our presentations with a safety moment. And Gary, I'm going to turn this over to you now to give our safety moment.
Okay, yeah, next slide. I took this photograph, I don't know, maybe 2007, 2008 timeframe. I was actually working for an owner, and we were installing an HDD. This is a 42-inch HDD in kind of a remote site. So basically, we had a couple employees that were working together. One got called away for 5 minutes, to go help someone else. And during the course of that time when he was by himself, something happened and he got hurt fairly badly. It wasn't life-threatening, but he was definitely hurt very badly.
Yeah.
So, we called 911, tried to get an ambulance out there. The ambulance came out, or the fire truck came out first. And determined an ambulance couldn't make it into the location. So we tried to load the gentleman up into a stretcher, put him in the fire truck, and bring him back down. And during that period of time, I worked with the firefighters to kind of travel around to try to find a place to land a helicopter. They were, like I said, they weren't thinking an ambulance would even be able to make it into the site. So we spent a little bit of time trying to find a place to land a helicopter. And each time we found a location that was big enough, the helicopter would circle, and they were always reluctant to land in all the locations because they were afraid that there would be flying debris would damage the helicopter.
Yeah.
So eventually we decided we had to turn off all the lights and move all the equipment that we could move away from the exit pad, and land the helicopter on the exit pad, which is what you see here in this image.
So that's our helicopter there, and of course the pipe string behind it. Yeah.
Yeah. So we were able to medevac the gentleman and get him to the hospital, and he was in the hospital for a pretty good period of time, but he recovered fully. But the thing that we all took away from there is these remote sites, things happen in an instant, and we were sort of we had a pretty good plan to get people evacuated, except for in this one location, because it was so remote. The mat road was so long that they were just afraid that how hard it would be on him to actually
bouncing along the mats.
In a stretcher in the back of an ambulance, or if the ambulance got stuck or something.
Right.
So it's just important to think about the things that that can happen, and also the things that there's a remote possibility that they may happen, and how will those occurrences be managed during construction. So
yeah,
it's you always, we always have so many things that we think about safety wise, rotating equipment, loose fitting clothing, rings on your fingers, but some of these other things, they don't happen enough to where we're cognizant of them all at all points in time. So
right. No, it's definitely a good reminder about preparing for the unexpected. And, if you're going to be way out in the bush somewhere, that you've got a fallback plan if you need it.
Yeah. What we actually did at the end of this, after this occurrence, we actually went around and found places that land the helicopter, if we needed it later on. And we actually put coordinates on signs there so that if you were the one calling 911, you had everything at your disposal to get a helicopter out there immediately. And fortunately, we didn't have to do it anymore.
Right. No.
But had we not went to that extra step, who knows what may have happened afterwards. Yeah. But definitely an eye-opening experience, one that I'll never forget.
Yeah, it's certainly a lesson learned. Okay.
Absolutely.
Well, thanks, Gary, for that. We'll move on to kind of just give an overview of what we're going to talk about today. We're going, we have a limited amount of time. We're going to briefly introduce the technologies, HDD and Direct Pipe, and we realize that a lot of people on this webinar are already familiar with it. Some of you may be less so. We're going to spend just a few minutes going through what those technologies are, and that's going to be important later when we talk about how they relate to the geotechnical risk. Equally, perhaps briefly, we're going to talk about geotechnical due diligence, and then we're going to jump into the geotechnical risks and consequences when we might consider direct pipe. Usually these projects that we're involved in anyway start as an HDD, and somewhere along the line, some of them, for one reason or another, we end up with a direct pipe. And then we'll also talk about during construction what sort of risk mitigation tools we have for that. So,
Hey, John, I would just say too, a lot of people, as it relates to direct pipe, I think we're seeing more and more of those, but a lot of our owner colleagues aren't really understanding of the limitations of direct pipe and how that can also relate to HDD. So, that's, I think, one of the reasons why we're seeing them start out perhaps as HDDs and then, mobilize towards a direct pipe later on in the process.
Right. No, good point. Okay, so with that, if you're prepared to chat, we're going into our trivia question now. The next slide is going to be our first trivia question. So with these, I've included a quote that has a lot to do with what we're talking about today, and then there's a picture of a famous geotechnical engineer, which I think that's kind of an oxymoron to say famous geotechnical engineer, but for those in the business, you probably recognize this gentleman. And I'll let April tell us if we've got a winner.
We do. We have Travis Gerber. Is that how you say his last name?
Excellent. That was fast.
So fast.
Okay, so for those of you wondering, this is Ralph Peck, one of the fathers of soil mechanics. So hopefully you had a moment to also read the quote there. So we'll jump into HDD, just an introduction to the HDD technology. Maybe I'll let you, Gary, if you want to kind of talk through this.
Yeah, HDD typically begins by establishing entry, workspaces on either side of the feature or the obstruction that you need to cross. We usually call it entry or exit points. Entry points where the rig would be positioned typically, and exit point would be where you would fabricate the pipe. On the exit point, you would generally also have some ancillary equipment, excavators, perhaps mud systems, and things like that. And then basically you just start drilling from one side to the other and punch it out on the exit side. There are alternate options or alternate methodologies that we often use more so now than probably in recent past, but where you do a parallel intersect, and in that instance you drill from both sides of the crossing and kind of meet somewhere along the path, and usually in a location where you're tangent in both the horizontal and vertical planes to make the intersect a little easier.
Right. So I think as regarding geotechnical considerations, important things also to bear in mind are you're dealing with an open hole. You're moving all of your cuttings through that open hole back to your entry pit, or after you've established an exit pit, you're to one pit or the other in an open hole, and they're traveling along within the soil formation. So they're
around the inner space of the drill pipe.
Completely dependent on that formation to contain those cuttings. And then we have to put a lot of pressure at that bit in order to get those cuttings to circulate and clean the hole out. So there's quite a bit of downhole pressure involved.
Yeah, and that's one of the good things about the intersect. Oftentimes people use an intersect just to reduce those annual pressures, reduce risks.
Right. And so after the pilot hole, the next typically the next phase would be to ream it out.
Yeah, usually 1 to 4 or 5 passes, depending on the final size of the carrier pipe and the size of the tune you started out with, your pilot hole diameter.
Right, and maybe a swab pass and then pull back, and then we're done. So again, we're keeping this pretty short. Obviously, we do a lot of presentations where we go into a lot of detail on these things, but just a brief introduction. So And again, the important things to take away as far as from geotechnical, you have to have material that can contain those cuttings and the return. You have to have material that's not going to ravel and fall apart on you, and it's also not going to fracture on you.
Yeah.
And so, you know, it takes a special material.
Yeah, and I'd also say too, drilling fluid is incredibly important in all phases of the HDD operation. You know, that typically goes without saying, but the rheology of the fluid is also very important. You know, one of the things that I see oftentimes is, you know, people treat drilling fluid like a byproduct of the process, but in actuality, it's an integral part. You know, you can adjust the rheology to, you know, to get cuttings out of clays, you know, where it may ordinarily be reactive and expansive.
Right.
And, you know, that's a different fluid rheology than what you would have in a rock crossing, where you're just trying to get rock chips out, and the rock has enough, especially like that igneous type rock, where it has a lot of strength and you don't really have to worry about fracturing the formation or anything. You know, there you're
just trying to keep it in suspension and get it out.
There. Yeah, absolutely. The chunks are typically bigger too, so you have to have enough. The fluid has to be strong enough to suspend the cuttings and keep them suspended on the trip out.
Yeah. Okay. So briefly on the direct pipe side, the direct pipe, you know, is similar in terms of the profiles that you can build. We often see direct pipes that are built along a previously designed HDD profile, but you can go shorter and shallower with the technology, because all of your cuttings return, all the fluid systems are within a steel casing. So everything happens within that steel casing, and then at the face of the machine is where the soil or rock is excavated, and it's combined with the slurry and then pumped back to the separation plant at entry. One of the differences would be you'd have a prefabricated pipe string would be located behind the entry point, whereas with HDD, it's typically located behind the exit point. A couple things on the equipment. The two main pieces of equipment we'll just mention briefly are the pipe thruster machine. That was the innovation that Heron Connect came up with in the early 2000s. And that allows the steel pipe to be prefabricated in long sections. And then the machine has a clamp that just grips on the pipe and then thrusts it into the ground. And then on the leading edge of the direct pipe, this sketch sort of shows one that's just about to punch out. So it's essentially complete. You have more or less conventional microtunnel boring machine.
The other important thing too, probably here is, you know, relative to HDD, you know, the angular pressures are lower because basically it's just lubrication in the circuit.
Yeah, much lower. You don't have to. You don't have an open hole, you have a cased hole, you don't have to pressure everything up in that open hole to return the cuttings. And then you have the microtunneling sorts of excavation technologies that can handle some ground, and we'll talk more about that HDD can struggle with.
Yeah, absolutely.
So just to give a general idea of kind of what direct pipe is capable of, I think a lot of people maybe have an idea of what HDD is capable, but direct pipe has some limitations based on primarily on the equipment in terms of the length it's capable of, and then it has also limitations on the appropriate geology. So the appropriate geology is on the secondary x-axis or the x-axis. And it's at the upper x-axis. Boy, I've been struggling with that here. And so as we see, we go from clay and silt to, cobble boulders and then up to very strong rock. And we see that as the pipeline diameter, the MTBM diameter increases as the y-axis descends, and you can go less far and through less competent material with smaller diameter MTBMs.
Yeah, this is kind of counterintuitive if you think about it from an HDD perspective. Usually the smaller diameter pipe, the further you can go.
Right.
And it's kind of opposite, with direct pipe. And that's one of the things I think a lot of folks struggle with. They think, 30 inch or 36 inch, we can go as far as you want to, but in reality, you're, 1,000 feet-ish, on something that
1,500, you're kind of up against some limitations there in terms of the equipment.
Yeah.
When you get into the bigger machines, you got a lot more robust machine. They're electric driven, so you can do a lot more and go a lot longer, but it's not an unlimited sort of thing. Yeah.
Yeah, absolutely.
And another thing, while we're on this slide, And this is from our draft manual of practice that we're putting together for ASCE. It's a figure that's in that manual of practice. But the other thing to point out, I think, is that with that microtunneling technology, you really can't tackle, or it's suggested that you don't try and tackle very strong and abrasive rock.
Yeah.
And so you see, as we get over here, rock that you could tackle with an HDD with special tooling, and it's done. It takes a long time, but the equipment manufacturer really doesn't like to recommend tackling that with direct pipe. So a couple of considerations there, and we're actually ready for the next trivia question. So everybody, kind of wake up and get ready to type. We've got another question here. And this one's maybe easier. The mentor of the first answer. Oh wow, yeah, they're coming in.
A lot of right answers, it looked like.
A lot of people know who that grouchy looking dude is, huh? Okay, so that's Carl Terzaghi, the founder of Soil Mechanics. So even a regular civil engineer might know that.
Yeah.
You maybe don't have to be a geotech to know that.
Yeah, a lot of people know Terzaghi.
Yeah. Okay, and it's an excellent quote. Soils are made by nature, not by man, and the products of nature are always complex. And something that we've got to keep in mind as we look at these trenchless applications. It's easy to draw a line on a piece of paper. It's a lot more work to try and figure out if that's actually buildable based on what's in the ground.
And the other thing about that too is you have engineers, like especially people who are used to dealing with steel, and Poisson's ratio is always the same, Graham's modulus is always the same, but in geology, soil mechanics and rock mechanics, it can vary dramatically in a very short distance.
Absolutely.
So
it
really
can and does.
Yeah, absolutely. That's something to always think about.
Okay, so we'll, as we briefly touched on the different methods, we will briefly touch on geotechnical due diligence here for the next couple of slides. And then we'll get into the risk and how it relates to trenchless construction. So when we're talking about geotechnical due diligence, we're talking about drilling soil borings. This is obviously kind of a specialized setup. This is one of our drill rigs from our Baton Rouge office down on the Mississippi River drilling on a barge. But we do that fairly routinely. We obviously do run-of-the-mill geotechnical sort of work as well. We also do work with all-terrain vehicle type rigs very often. So those are a couple of options for the drilling rigs. Once we take the samples and get them back in the lab, sieve analysis, grain size, trying to figure out what that material is, what the percent of gravel or larger kind of material is often very, very important in terms of HDD. Once you run this test, then you can produce this sort of a graph and get a handle on kind of where what material you're dealing with and what you're going to be trying to go through. One of the other really common things that we run is plasticity. This is a shot of an Atterberg limits setup, and we also do a lot of strength testing. The strength is important, particularly with respect to hydraulic fracture and getting a handle on those risks. And so in fine grain soils, we'll do that. We've got a full on triax set up on the left, and then just a unconfined test there on the right.
And I'd say too, that a lot of folks don't understand, there are limitations in what you can do with certain test specimens. For example, if you do an SPT test, you're very limited in the type of test you can run. If you are able to collect an undisturbed sample with a Shelby tube or something, you're able to do a little bit more sophisticated testing. But
yeah, that's absolutely true. So kind of summarizing on the geotechnical due diligence, and this was a picture of a drill rig on a fan boat that we rarely get to do that, but every once in a while we'll even get to do that. But you know, we want to look at doing some initial mapping, perhaps look at geologic hazards, landslide, those sorts of things, if it's applicable, karst. You know, those things all play into the construction risk and the risk of the lifetime of the project. Once we think we have a handle on what kind of soil and rock we're expecting, then we do the geotechnical exploration. We'll look at groundwater. It's really important to understand, particularly if you have a crossing with an elevation differential, where your groundwater is at. We'll talk more about that in a moment. And then we talk about, or then we look at some of those laboratory testing, index testing kinds of things that we just showed slides of. And then if we do rock core, if it's a rock project, then we'll do unconfined testing and also abrasivity, which is a measure of how the resistance of the rock to basically to a steel tool. So how much tool wear you can expect and effort it's going to take to get through something. And I think that, you know, one of the things, Gary, that we run into a lot is a question of what is the appropriate amount of due diligence?
Right.
And, you know, you hate to be the classic geotechnical engineer and say, well, just judgment, you know, you got to use your judgment. But to a large degree, there is a lot of judgment in that.
There is, yeah.
And part of it is your past experience with that area. Part of it is what the geologic mapping is showing you, what the risks are, you know, what are you going under? Does it, you know, how sensitive a feature it is, those kind of things. But it does take, you know, a fair amount of thought to understand those and develop a good program that you can be comfortable with. I mean, at a minimum, I would say, and we do see occasionally, we still see crossings come across our desk that, you know, say someone wants us to look at helping them out on construction or something, and there's no geotech.
Yeah.
And so we still see that even occasionally, and I'm sure some of you out there in our audience see that as well. You know, to our way of thinking, that's not doing appropriate due diligence if you don't have any geotech.
Not at all.
You know, and so you might go from that extreme to doing borings every 500 feet or even closer, depending on what you're looking for.
Yeah, and you know, I've never been, you know, going back to my history on the project side. You know, when I work for owners and go to different projects. Can never remember a crossing where we said at the end, you know, when it was completed, wow, we got too much geotech data. If we would only have saved some of that money for something else.
Right.
It's usually the opposite. You know, had we drilled one more boring, you know, maybe we would have found this, and it could be perched groundwater or, you know, or anything. And on the other side of that coin too is if you don't, on the owner side, if you don't have geotech, not only are you not helping the contractor to set themselves up to be able to execute on schedule and on budget, you know, you don't have any way to protect yourself from a differing site conditions claim.
Right.
If you run into, you know, geologic mapping may indicate you're going to hit, you know, soft sedimentary rock, but there may be some kind of intrusive body, igneous body in there that doesn't show up on geologic mapping. So
yeah, well, and that's a good point. And you know, we've seen some, you know, we're aware of some projects recently that you know, were designed to be at a certain depth, and the geotechnical exploration just stopped when they hit rock.
yeah, right.
And so it's kind of, you know, from our perspective, probably not the best due diligence there either. If you stop when you hit rock, because you don't know what that rock is, and you don't know what to tell the contractor to expect. You don't know if there's risk of voids, or, you know, if it's real weathered and fractured rock, HDD might not even be a good option there.
Absolutely.
But if you stop, you know, it's one of those things, you stop, you don't know.
Yeah, we usually like to go, you know, through at least through the tolerances.
Mm-hmm.
And then if we hit rock in an unexpected area, that's a whole different, you know, circumstance, right? You know, is it a lone floater that's, you know, that's worked its way up, or is it indicative of something more? You know, or is it, you know, if you hit it with an SPT sample, or is it just a piece of gravel?
Yeah.
You know, like a big cobble or something? Is it just an isolated incident?
Yeah.
And that kind of goes to one of the things that I think that we do really well is, you know, we assess the situation real time when we have people in the field doing borings. You know, we're talking daily. And then we are able to communicate with our clients and say, hey, we're hitting something unexpected here. You know, we think we should, you know, drill another
Yeah.
boring and,
Yeah.
and further.
Or you may be looking for a sand layer to put your
Yes.
HDD in, and you've gone 150 feet, you're still in clay, but that doesn't mean you should stop.
Yeah.
You should, you know, probably keep going and see if there's a chance that you can find that sand layer.
Yeah.
And we'll talk more about, you know, why you would want to do that in a minute.
Yeah.
But, you know, so it is important to have that, the trenchless designer and the geotechnical folks, if they're not the same company, at least talking to each other throughout the exploration process, and, you know, picking up the phone and saying, hey, here's what we're seeing. Can we stop the hole here?
Yeah.
Or do we need to keep going? You know, we see, you know, the other point to make with that, I think, is early, geotech is early in the process, you know, and you think you might have a depth, it might end up being somewhere else. You know, we would always want to go at least 20 feet below that bottom tangent elevation. So, you know, you have good coverage in case the contractor needs to go deeper for whatever, or does go deeper for whatever reason. You know, like you said before, there's not an opportunity for them to say, well, you know, this is a different condition.
Yeah.
If you don't have the data, it's just by definition a different condition, you know?
Yeah, absolutely. You know, the contractor, they generally want to, oh, sorry.
Yeah, go ahead.
Yeah, I was just gonna ask, one of the questions that came in was, what's your rule of thumb for number of borings on a crossing?
Yeah, that's what we were just talking about, like from a judgment perspective.
Right.
And I see we've managed to kill a whole bunch of time on this slide, Gary. You know, usually around 1,000-foot spacing or something like that. You could go less or more depending on the geology that you're expecting, and, you know, kind of how critical the drill is, and what the risks are that you're expecting. But that's a tough one. But that's kind of a general, you know, first blush kind of a number, I think. So I think we got sidetracked, Gary, and we're gonna have to catch up. So
sorry about that.
no, I think it was my fault. That kind of geotechnical stuff got me going, and here we go. Okay, so well, let's go into our first kind of what we want to look at from a geotechnical perspective and how it relates to risk when we look at coarse grain soil. And we're talking there about, you know, primarily not sand so much, but some with sand, but really, you know, gravel, cobble, weathered rock that's going to break down as you go through it and really act like a gravel and a cobble as you're trying to get it to come out of the hole. So let's look at this first. You know, the other point to make, I think, quickly is having an understanding of how cemented that rock is. So how stable it is when you go through it, if it's going to collapse on you because there's no fine material at all, or if it's, you know, going to be able to hold a hole open.
Or occasionally out west, you can find caliche where it's chemically cemented.
Right, right. So talk us through this photo here, Gary.
Yeah, this was a project from a very long time ago, probably early to mid 2000s. And as you can see here, you know, we're basically augering out the casing. We had put in a large diameter casing to drill this river, and then we centralized a small diameter casing for the pilot hole. So, you know, we had some pretty good geotech, but, you know, when we started installing the casing, lo and behold, you know, we found a lot of granular material.
A lot of oversized stuff there. Yeah,
which is very difficult. And if you can see, those are river deposits or maybe glacial deposits, how rounded they are. They've moved a lot. And it's really difficult to drill a pilot hole in those. The tooling will actually ride up on them. They actually function like ball bearings. But you hit a big, you know, the one that's large enough, and it'll push you up, and you can actually see it in inclination changes.
Yeah.
Whenever you're getting onto something like that.
Yeah.
Create a lot of havoc for the driller.
Right. So here we've got a reamer that's sheared in half, I guess, kind of from being caught in a formation, and the formation sort of collapsed on it and just sheared the tooling. Yeah,
so this is probably, you know, this is a flat cutter. You typically see this in sands and clays and stuff like that. They don't, you know, they're not built to handle, you know, very big chunks of material, because basically all they're doing is there's a little bit of hydraulic cutting action on the end and some mechanical cutting action with the teeth, but they basically mix the stuff together. They have like little spokes inside there. This one hit something pretty bony, and it probably got hung up, you know, perhaps. And, so the driller probably trying to get it out, you know, did some
Yanked
did some
on it a
pretty good
little.
damage.
Yeah. So here we have a barrel reamer, looks like maybe got pulled
Probably-
past a boulder or something
Yeah.
like that.
Probably some cobbles or a boulder, you know.
And you wouldn't really see this in rocky ground necessarily, so it was probably an unexpected.
Probably very much probably an unexpected occurrence. You would ordinarily not run something like this in anything that, you know, other than sands or clays or something. Basically, you're just trying to push the hole open for something like this.
Prepare it to receive the
Right.
carrier pipe, product pipe, whatever. Yeah.
Definitely some damage there too. Probably driller probably got hung up there as well.
Yeah, yeah.
But,
Yeah, it looks like it.
yeah. Looks to me like this one, you know, probably getting ready probably during pullback, perhaps the pipe got hung.
Yeah.
Ripped the pull head off.
Rip the pull head. These are all things that you don't want to see on your project.
Yeah.
If we, just to be clear.
Yeah, when you, whether you're the driller or the owner, when you look down in the hole and see that, it's a very
not a good
concerning sight.
Not a good day.
But usually you know, the exit side would let you know, like the pipe stopped moving.
Right.
Like, oh no.
Oh, no. Because we're still moving over here.
Yeah. Oh, we're moving faster now.
Yeah.
Uh-oh.
Yeah, but we're not carrying very much of a load anymore. Yeah. Yeah. So here's actual damaged product pipe. Again, something that probably the result of bony material, rocks falling in the hole.
It looks like some, probably some weathered rock right there. That looks like some weathered, you know, what limestone or something to that effect, and, you know, on the left-hand side. And you can find a lot of that in, especially down in Florida, Georgia area, you know, decomposed limestone tends to float up to the soil column, and you think you're above it, you know, through all your due diligence, you know, you think you've determined that bedrock soil interface, but you can always find things like this, especially if you don't do enough geotech work. And
Right.
you can also kind of do some geophysical work too, to help in certain instances, to help kind of true up or validate what you're finding from your geotechnical explorations.
Right.
This is another one from the same crossing that we had earlier with the, you know, the cobbles coming out of the casing.
Yeah.
During pilot hole, I mentioned earlier, you know, you can start getting the bit to ride up when you're drilling the pilot hole on some of those larger cobble pieces. And, you know, you can't, oftentimes they'll just roll around, you can't get through them. So apparently, you know, here, I think we hit one that was a little bigger and couldn't get through it, and just, you know, pushed really hard on it and
Bend it up.
bent up a piece of drill pipe. And you know, the thing about bending a piece of drill pipe is you never just bend one. It's
Right.
usually a couple.
Right.
And they're very hard to get out of the hole.
Right. So, you know, talking about things that you might be able to do in construction. Obviously, the first one, I guess, would not be in construction. It'd be before construction, would be to avoid a risky area. But there's also additives that you can use to help the fluid properties to carry the material. This is a picture of a hammer, you know, which a lot of owners don't necessarily like to see because of the stresses that they put on the pipe. Or, you know, the other option there would be direct pipe. And we mentioned that, you know, the microtunneling technology can handle that gravelly material pretty well. So, and we've done a number of direct pipes just to mitigate that risk from an HDD. Started off with an HDD design, and then you end up with a direct pipe.
Yep. The other thing too is you can say is if you do enough geotechnical due diligence on the front end, one of the avoidance strategies may be, you know, going deeper and getting into rock if you can find it, or something maybe a little more competent.
Yeah.
And
good
then
point.
isolating the ends with casing, you know,
Mhm.
the tangent ends, you know, do some of that worse stuff, you know,
Right.
more
Right.
larger granular pieces.
Yeah, no, that's a good point. Okay, so let's talk about fine grained soil. And again, I'm going to move faster because I see we're running short on time. So, you know, some of the things we think about with fine grains is more like how it's going to chemically react.
Right.
One, you know, is it going to swell up when we hit it? Is it going to swell in on the pipe? Is it also going to be a risk of fracturing?
Yeah.
And really that's if you think about a piece of clay, once you've fractured it, you know, if you pull it apart or break it, it's done. You know, sand, you move it around and it just gets into a denser configuration between the grains.
Yeah.
Clays, you fracture them, they're done.
Yeah.
And so those are primary risks we see with fine grained soils. This is a picture, we got a couple of pictures here of inadvertent returns or surface releases. Obviously, this is a big thing in our industry right now, has been for some time, but it continues to get bigger and bigger, that this is something we've got to avoid. And a lot of the new guidance and the regulator guidance speaks to this, and doing an analysis on the front end to say, what is our risk of doing this? And so.
Yeah, and going back to my history in the industry, and you've probably seen this too, early on, when I first started in, around 2000 or so, very little was done to assess these risks. And we've had some occurrences over the last, 6, 7, 8 years or whatever, that have really driven it to be, more due diligence and the actual correct kind of due diligence as well.
Right, right. So this is another example. This is a shore approach. We see we've got an inadvertent return out into the lake there. This is one in a neighborhood, and we were joking earlier, Gary, anybody that cuts their bushes like that is not going to want to see an inadvertent return in their front yard. I mean, nobody does, but this is obviously a pretty particular person.
Yeah, we've always said in the industry over my time in anyway, the fluid on the grass helps make the grass greener, right? Well, I'm not sure if the person that owns this place would believe that or not.
They're not buying that. Yeah. So one of the things, and I'll just mention it, we don't really have time to go through these figures, but one of the things that we do with direct pipe, we mentioned the pressures are a lot lower. It's a mitigation, and we've seen several levee drills where we couldn't get the HDD to work. We did a direct pipe and reduced the risk thereby. And we've got a couple of those kind of projects actually going right now. And so that's, again, a potential mitigation for hydraulic fracture risk. Again, the number one would be avoid, and then always prepare for it, have the supplies on hand, the equipment to deal with it should you have one. We always recommend monitoring pressure during pilot hole, and see if that pressure is looking like what we expect, or are we seeing spikes? That could be indication that your hole's not very well cleaned out. We need to do a better job of keeping the hole cleaned out. Yeah, production rates too, if you compare production rates and the trends, the annual pressure trends, those are good tools to use to make informed decisions on the driller's behalf. Yeah, and then we mentioned earlier pilot hole intersect, and then direct pipe as ways to keep those pressures down. If your formation can't handle anything, maybe you can't even get one of those to work, but those are all tools in the toolbox to reduce those pressures. And fluid rheology is really important in fine grained soils too. That's one of the things where where if you're going to have a mud engineer on site, that's the place to do it. Yeah, for sure. So looking at the moving on to profile elevation. So this is kind of a design risk, a geometry risk, but it's directly related to geotechnical risk in that depending on the soils you're going through or rock, this may not be a big deal, or it may be a huge deal. And so a couple of things that we look out for are, do we have perch groundwater? So this is actually a drill we designed in Iowa. And I know you thought Iowa was flat, but there are some places in Iowa. At least one hill there. So this is, so one of the things we would look for is, on this boring here, do we have a water situation up here? And we're going to start the drill most likely from the low side. And when we drill up to it, are we going to, is it going to flush? Yeah. So that's one thing we're looking for. And then another thing, we're looking at the kind of material we're drilling through. Does it seem like it's going to stand up? Because you're going to have no fluid in this area of the hole. So that this is anything above the elevation of entry is called dry hole. It's above the fluid equilibrium point. So another very important thing to keep in mind when you've got significant elevation difference, as we're showing on this slide here. And this one, actually, we did end up with a sinkhole towards the top. We had to do some additional things during construction to mitigate some of the things that were happening. We did get it in, but it was definitely one that was challenging. Yeah. And if you combine that situation with with fine grained materials where they flocculate, create clumps and start running down. Yeah.
Yeah, it can hold fluid up until it flushes, and then you get a lot of drilling fluid.
Yeah.
And we'll talk about that in a minute. But
Yeah, so this is a crossing in Utah that we got called out on, and this is a sinkhole near a highway. In the background, there's an interstate. So obviously, with these kind of things, we're looking at, well, not only are we disturbing the ground surface, we've also got life safety things.
yeah,
And so we have to really, really be serious and considerate of how we approach these. We want to protect the public. It's our first duty. So.
yeah. A lot of times the pavement will bridge something that it'll be a catastrophic failure, and
Right.
that won't give you any warning.
Right. So I mentioned the groundwater. Talk us through this slide briefly, Gary.
Yeah, this one, I think this one was also one where perch groundwater
Yeah.
was intersected.
Yeah.
And basically, once
Trying to control it, and it's going everywhere. And yeah, you just have that that elevation head on your water, and you just sometimes very little you can do with it.
yeah, especially if it's coarser granular materials, where and you get a lot of precipitation or something, it's going to be constantly recharged.
Yeah.
And then, you're going to have to, as the owner, the owner would probably have to do something dramatic here to manage groundwater for a period of time. Or, there's also, you could potentially drought, but, you never know how effective that's going to be.
Yeah. Yeah. So I'm going to go through these next couple slides really quickly. This is obviously in a neighborhood. We've got an elevation differential, and we've got some pretty good sinkholes there where
Some of that dry hole again.
yeah, some of that dry hole. This is in a park, and this was in Washington State.
Washington State,
Yeah.
out near Auburn.
Yeah.
A very big elevation differential there.
Yeah,
And
I think we show that on this. This kind of gives you a sense for this same project.
yeah, these last three slides are all the same project.
Yeah.
And this is at the top of the hill looking down over the river onto the drill pad. And you can see, we were prepared here to address or handle the flush.
Yeah.
But, the dry hole at the
And
earlier
look-
slides created a whole different set of issues. as
Look at
well.
the size of that pit to contain the whole flush.
That was probably 250 by 200 or something.
Yeah.
It was humongous.
Yeah, but that's what you have to plan for.
Yep.
You plan for the volume in the hole, and it's
Yep.
probably going to come all out on you at once.
Yeah,
You
we
gotta
assumed-
prepare.
I think we assumed that the hole is going to flush, at least twice during each pass. So we built the pit accordingly, and we also bermed around all the equipment with Jersey barriers. And from the actual mud pit in front of the rig, we put a 42-inch casing in as a culvert that led to this pond here, so that we didn't have to, if something happened, we could abandon ship and get out of there and let it handle itself.
A lot of thought into that mud handling. So again, just to kind of summarize on the elevation differential, first avoid, and that may go back to routing, and then prepare for the whole flush. There might be some things that you need or want or need to do to the soil in the dry hole area to improve it so it can handle the HDD better, or you might have to look at a direct pipe there too.
And the direct pipe piece is an important thing to think about too. You probably remember it was a few years ago, we had a direct pipe we were helping out with, and the elevation differential was so significant that the MTBM, the seals on the canister itself would only, we had to drill it from one end or the other. We couldn't do both, because of the elevation differential and the pressure put on the seals.
Right. So we'll briefly mention hard and abrasive rock. I think that's probably pretty easy to grasp. I mean, if you can't cut it with steel, then, or it takes a long time or uses up a lot of tooling, then that's your hard and abrasive rock. So this is a pretty good graph correlating abrasivity and unconfined compressive strength. If somebody's interested in that, reach out to me, I'll get it to you. This is an example of some tooling that had some section loss just from going through some abrasive.
Yeah, hard and abrasive rock, the production rates are going to be really slow. So you're going to have instances where, you have a lot of reverse bending cycles. You're not moving the drill pipe very fast.
Yeah.
So you're losing metal, at the same time that you're having these reverse bending cycles. So it can lead to a lot of fatigue as well.
Right. We got a couple of shots here, just equipment that's getting worn down by rock.
This stuff is just getting killed by rock.
Right. And then
this is kind of what we're talking, I mentioned earlier, this is most likely a fatigue failure based upon where it is in the string.
Yeah.
And so whenever you have it's important to think about, your tooling going into some hardened abrasive rock. How often is your drill pipe inspected? Are you gonna have it inspected again during the process? There's a lot of things to think about there to set yourself up for success.
And so then we get into pullback and kind of some things that, if you've got a bad hole or if you've got just abrasive rock, abrasive ground, and things to be considering of, getting all your coating and even metal loss of your pipe.
Yeah, coating damage, you shouldn't go into a rock crossing thinking you're not going to have coating damage. And the previous slide, you saw some metal loss in there too. That in certain instances, you may have chunks of material left in the hole or cuttings that are pulled in a low spot or something. And when you pull the pipe across that, you could see not only coating loss, but metal loss.
Right. And then your pipe might not even be acceptable for the job it's supposed to do. At that point.
Or you may end up having to pull more pipe through until you can, one of the things we've done in the past is UT testing on the pipe when you see metal loss. Just to make sure you have that wall thickness. And sometimes you may have to pull several joints until you get a couple that you can.
So your pipe's wearing the rock out and eventually,
eventually it'll flatten it out.
That's an expensive way to wear rock.
Yeah, it is for sure.
So kind of summarizing on the hard and abrasive rock, avoid if you can, not always possible. Plan for long duration, plan to have a lot of extra tooling. You are going to have to change it out. And then additional coating. And then this is actually a picture of a fishing tool, getting ready to go fishing.
Yeah, fishing's not fun whenever you put it on the front end of a drill rig.
Right. And that's what happens when a roller or a piece of metal gets knocked off of your tooling because you're in rock and your stuff's wearing out, and you can't leave that in the hole because you don't want to pull your pipe over it.
Yeah, you can lose cones, and you can, as you shown in one of the earlier slides, you had the centralizer on the front of the reamer was very thin. I've actually even seen centralizers come apart where the metal loss is so dramatic that they're just worn out and fall off in the hole.
Right.
Those are very difficult to fish out.
Okay, so our final trivia question, and we're wrapping up. Just barely brought this under, April. I mean, I show 4 minutes. But this is our final trivia question. I guess if you answer either one of those questions, because I know this gentleman's maybe a little less famous.
Yeah. So let's go with Andrew Porter on this one. Arthur Casagrande.
Yeah, excellent.
Someone said Castleberry. Too funny.
I think the haircut.
Gary.
The glasses and the haircut.
No, you're more handsome. I'm sorry. That's it's good.
Well, we appreciate the opportunity, and hopefully folks enjoyed it. April, do we have some questions we can get to? We got 3 minutes is what I show.
Yeah, I don't have any questions up here right now. If you guys want to type any in the chat, we can see it. As people might be thinking, just a reminder that we'll be sending out a link to the recording. So if you missed some of it or you want any of your colleagues to see it, you can share it. It is on a private Geoengineers YouTube link. And then in that email, I'll also include a certificate of completion, and that allows you to self-report those credits. There is another question that says, how did you anchor the fan boat for aquatic geo drilling?
Those were on little screw anchors, I think, if I recall correctly.
Okay, and then how long can we drill?
Drill, baby, drill.
Drill, baby, drill.
How long can I think that is how long? What's the maximum length? Gary, you want to talk to that?
We have several that we've done since I've been here that were 12,000 feet in length. I've heard of 17, 18,000 feet in length. It's it really depends on the geotechnical conditions.
The diameter of the pipe.
Yeah, the diameter of the pipe and geotechnical conditions.
Yeah. So that's a good question, because that is continually being pushed.
Yeah.
As equipment gets increasingly sophisticated and good, and just the industry continues to advance. It's a young industry, particularly direct pipe. I mean, that just started in 2007 was the first one. So.
And we have a lot of contractors that are very innovative.
That's true.
The way they apply tooling and how they're trying to take things from the oil field and adapt them and utilize them in the HDD industry. So
Right.
I think the sky's the limit, honestly. I think
Yeah.
we'll continue to see that envelope pushed every year.
There you heard it. Gary says every year. New
Every-
record.
Every year, new record.
Too funny. And you guys know this question pretty well. How much does direct pipe generally cost relative to HDD?
Yeah, we get that all the time. It's I gotta say, it's a new technology, and initially it was dramatically higher. I think more and more we're seeing those prices come down. And then the other point I'll make before I really answer the question is, on a shore approach, the costs are actually comparable, and direct pipe can sometimes beat out HDD on a direct dollar-to-dollar basis. If you move onto the ground, and typically we don't see direct pipe done where you could do an HDD, so I'll just make that statement. But generally, if you could do an HDD in a location, direct pipe's going to be 2, 3, 4 times more than what an HDD per foot would have been. It's kind of the range we're seeing, but again, it's all over the place. But that also goes to why we start with HDD. It's typically and don't go to it until, or don't go to direct pipe until for some reason we encounter something that HDD isn't good at.
Yeah. And I'd just say too, on the shore approach piece for direct pipe, the reason why it really helps out is because you don't need marine support for as long as you would with an HDD.
Right. Yeah.
And so marine support is usually very, very expensive.
Yeah.
And the other thing too is, whenever you're conducting the operations from the land side, you don't have a lot of delays, weather associated delays, where you wouldn't actually be able to work on the barges or something too. So it's also another thing to think about with direct pipe.
No, that's good. Good point.
Yeah. Another question related to direct pipe is, how widespread is direct pipe use in the US? Basically looking at number of contractors as perhaps compared to number of larger HDD contractors.
I think there's, my memory's fading a little bit, but I think there's been about 60 some direct pipes done in North America, maybe 70 now. And so it's kind of established pretty well. A lot of those are in Canada, but probably the majority in the US, I would say. Andrew might correct me, but as far as the number of contractors, you have 3 or 4, pretty established direct pipe contractors in the US. You obviously have however many HDD contractors you have. So, but there is enough of a group of contractors that you'll have competition. It's not a one-stop shop.
And then let's see here. Andrew Porter says USA has more direct pipe completed than Canada, as you know.
I know they're doing a lot up there right now. So.
And then another person sent a message that said, I saw a picture of metal coating lost during HDD, so I wonder about type of coatings used in cathodic protection. Can you guys elaborate on that?
We usually see like FB8, like 14 to 16 mils of FBE, and then somewhere between 30 mil, around 20 to 30 mils of abrasion resistant overlay on top of the FBE. And the ARO is typically, it's like a sacrificial coating. It's designed just to take the abrasivity of the formation.
So they followed up with, I wonder about using a good mechanical protection coating, such as a glass reinforced wrap.
I've seen a lot of things tried. I've even seen HDPE, or I haven't seen it, but I've heard of HDPE overlaying on. And I've heard of concrete, people trying concrete weight coated pipe. So there's a lot of innovative ways to address it. It kind of depends on the bend radii of the hole, because you get it when you start getting into stuff that's, more rigid than HDP or than ARO or FE. It really, you have to look at bending stresses and whether that material would survive the installation.
And pipe handling as well.
Yeah, and pipe handling too. Yeah, you put 4 or 5 inches of ARO on 42-inch pipe, you're going to have a very difficult time finding something to pick it up and support it during the overbend. Yeah.
Awesome. Well, that completes all the questions. Anything else, John or Gary?
Nothing here. Really appreciate the opportunity and everyone joining us, and stay safe out there. Have a good rest of your week.
Yeah, appreciate everyone's attendance. It was awesome.